Hello there, my name is Michael Maynard and welcome back to Gorilla Picking. Now, today folks, we are going to look at an amazing lock and introduce you guys to an amazing concept. The lock that we're going to talk about is this massive hunk of metal in front of me here. It is a thing called a Folger Adam mogul. Mogul is the name for this style and size of lock. It's a prison lock. The model number on this one is 110 and I have never picked this lock, folks. I don't have a key for it, so what I had to do was shim it open. We'll talk about that in a minute. It's an incredibly difficult lock to pick, despite the fact that it is entirely standard. It has got 5 ordinary pin tumbler type pins. You'll see those right here. There's in fact 2 spools and 3 standard pins here. But despite that fact, this lock is an absolute ocean-going bitch to pick. Now the reason for this, it has got a fascinating feature, and that feature is this thing right here. This thing is called a master ring. So this lock is master keyed, alright? And usually master systems make a lock very much less secure. Now in the case of this lock, however, and in the case of this master ring system, it makes it massively more secure. And when we do the maths on this in a minute, and don't get scared off by the maths guys, when we do the maths in a minute, you'll see why this is so much more secure. So the way that it works is actually quite simple. We're looking in from the back of the lock here, and you can see that the core just flops around inside the housing. So absolutely beautiful tolerances on this thing, and the core just fits like a glove in there, but it's flopping around in here. And the reason for that is that this master ring, which is about 3.5 centimeters long and about 3 mils in diameter, that slots in there like that, and it actually goes between the plug and the Bible. So this has a Bible up here with the springs and the drivers, just like any other lock, but in between those two things it has this very big ring. So what's it do? Well, it allows you to organise the lock for master keying. And if we zoom in a little on the keys on this thing, let's just zoom in a bit, not keys, pins, you will see, just let's zoom that back out a little touch, okay, you will see a couple of pretty interesting things. The first thing is, these are the key pins here, and they are massive things. I mean, they're just enormous. And they have got a ball bearing at the business end, so instead of having a pointy end, these things actually have a little dimple in them, a little sort of a half a hole drilled in, and a ball bearing rides in that. Now that is to reduce wear on the lock. It has got no function in the operation of the lock and in the picking. What it does do though, you can imagine this thing's in a jail, keys going in and out about 100 times a day. They want to reduce wear somehow, and they do that by putting a bearing surface there. Fantastic idea. But it doesn't stop there. We have got master wafers, so all but chamber 3 on this particular lock has a master wafer, and then up on the top here we have the drivers. Standard drivers in positions 1, 2 and 4, and these massive milk bottle style spools in positions 3 and 5. Now what I am going to do now guys, now that you've seen how it works, and now that you've seen that there's nothing really amazingly difficult with the pinning, okay, what we're now going to do is go to the math side of things and show you just how complex these things really are. Now again, you can see exactly how this is going to work, folks. The lock has, of course, 2 shear lines, okay? So when you are using the ordinary change key, so that's the standard guards key, then the core simply rotates, so the key pins are going to this shear line here. On the other hand, when you are using the master key, what you're actually doing is rotating the whole unit, including that master ring. So you can imagine if you've got the master key there, you're rotating this whole section, including the core, and of course, because there is just an ordinary cam on the back of this, that means that the whole unit turns, and it turns the cam as well. So the key point to remember here, folks, is that we have got master, wafers and drivers, just like any normal lock. The little ball bearings here are a complete red herring, but what we do have is 2 shear lines. That's the key point. Okay, so now we're going to get our bit of paper, and we are going to figure out why this is such a good thing. Back in a second. Okay guys, well, we're back, and what we're going to do now is the maths to figure out why this thing here, once I get it in front, this thing here with its extra shear line and extra components is actually more, and we're talking much more here, secure than a lock that doesn't have it. So what we're going to do is talk about pin states, and these are fascinating things, guys. Oh, and can I just do, I'm just going to make an aside here, guys. Please, I beg of you, do not get put off by the maths and science I have in my videos. I absolutely love picking locks, okay? And the reason I love it, honestly, is that it's all based on straight out pure mathematics and pure science. The lock doesn't lie, you know. There is just no room for interpreting this or airy-fairy that, you know. And once you know the science behind what we do, it just makes so much more sense. So we're going to talk about pin states. We're going to talk about feedback. We're going to talk about the lock leaking data, and we are going to talk about probabilities. Now, the first thing we're going to do, we are going to consider one pin stack in one standard 5-pin lock. So here we go. This is a very standard chamber. So here we go. We've got our key pin, we have got our driver, we've got our shear line going across here, and we have got our spring up above pushing everything down. So, you know, look, it could not be simpler. Now, there are 4 possible states that this chamber can be in. It could first of all be at rest, so it could just be sitting there doing absolutely nothing. Okay, fair enough. Second thing, the driver could be binding. So we might have a little bit of tension on the lock. It might be this chamber's turn to bind, and this thing might be binding. Okay, very good. We might then push the key pin up a little, and we might get the pin to set. So that's the 3rd possible condition that it can be at. We push that up and it's set. And then the 4th possible condition, we could push it too far, and the key pin could now be bound up here on the shear line, and we could be overset. Now, as lock pickers, and here comes some interesting stuff, guys, when you are single pin picking, what you are persuading the lock to do is leak data. Now, this is the feedback that we keep on talking about, okay? So what you do is you put a little bit of energy and information into the lock. So you've got a little bit of energy on there in the form of the tension. You've got a little bit of information going in there in terms of the pick tapping on the pin, and the pin feeds back information to you. It leaks information back about its pin state, and then based on that information we then know what to do. So if it's binding, we push it up until it sets, and we know what a set pin feels like. So it's again leaking information back to us about the fact that it's set. Okay, now we've got our 4 possible pin states, and we can get data back about them. But we've actually got 5 of these in the lock, haven't we? So let's think about all 5. Each 5, 1, 2, 3, 4, 5, can be in one of these 4 states, and the only one that we really are interested in is the set state. So to get this lock open, we need each of these 5 chambers to be at the one possible state that we need, and if we get them all to that condition, then the lock is going to open. Now, listen very carefully, guys. If we just do that at absolute random, okay, we have got a 1 in 1024 chance of that happen randomly. That is why raking works. This is what happens when you are raking with a bogatar or a snake rake, okay? What you are doing is randomizing this thing. You're pulling the lever on the slot machine, okay, and the little things are spinning round and round and round. And you do that long enough and you're going to get lucky. So 1 in every 1024 pin states, according to the law of averages, you're going to hit that perfect one and the lock is going to open. So this is why you can rake open reasonably easily a standard 5-pin lock. You can either single pin pick it and get the data about the pin state, so it's leaking information, or you can do it randomly. You can jiggle the thing with a bogatar and you can get 1 in every 1024 chances of the thing opening. Now generally you're either good at raking or you're good at single pin picking, and I'll tell you now, I'm a good single pin picker, I'm an absolutely crap raker. So for me it is better that I put data into the lock, let it leak information back out at me and set these myself, than it is to do it randomly. However, some people prefer the other method. Okay, that is a standard pin stack with no mastering. Let's now, and I'm sure you guys all understand that. That's pretty simple stuff, okay? So, next thing we're going to do, we are going to talk about a lock that has got a conventional master wafer system in there. So, here we go. It is just, nothing fancy about this, guys, nothing special. It's just the one that we looked at before, but it's got a master wafer in there now. So we've got one shear line, okay, because this is how normal locks work. We've got a driver, we've got a master wafer, we've got a key pin. Okay, now that adds a few extra possible pin states. So let's consider this chamber, okay. There are now 6 possible pin states. It could be at rest, we could have the driver binding, we could have this division set at the shear line, we could push further and have the wafer binding. Ignore that, that's an email. We could go further still and we could have the shear line at this point, so we set here, or we could ram the thing right up and overset everything and have the key pin binding right at the top. So we have got 6 possible states. But here's the thing, here's where it gets interesting. We can actually use 2 of those to get the lock open. Now this is why picking a lock with ordinary master wafers is so much easier, okay? So here is the maths. We all know this, okay? We have got 1, 2, 3, 4, 5 chambers. Very good. We have got 1, 2, 3, 4, 5, 6 possible pin states, okay? But we can actually use 2 of them per chamber. So our chances of getting into this thing, so the number of actual pin states that are any use to us, okay? 2 times 2 times 2 times 2, which is 32 possible states out of a possible 7776, which, if you reduce the maths down, is 1 chance out of every 243. So here we go, guys. Here's the hard, straight out numbers. Here's the maths that shows you why it's so much easier to pick or rake one of these than it is one of these. It's 4 times easier. Here's the goddamn maths. Okay, now, you will be aware that in prisons, if you're using a dirty great lock like this, you do not want to make it easy for somebody to pick this lock. So I would suggest to you that if you were going to master a cylinder like this with a system like this, then you just did the criminals a really big favour. Okay, so we don't want to do that, do we? Okay, what are we going to do? Well, why don't we use a more advanced system? Why don't we put a master ring in there? So, What does that look like? Well, I'm glad you asked. It looks a whole lot like this. So, here we go, guys. Real simple once you start looking at it, okay? Here's our key pin, here's our master wafer, here's our driver. Okay, we're all there so far. Now, instead of one shear line though, we've actually got two, haven't we? So we've got the first one here at the core, okay? And then we have got the second one here at the master ring. So we can either turn the core by itself, or if we pick to this shear line here, we can turn the master ring and the core at the same time. Now you can't do both, guys, and there is the nub of it. There's the key to it. So the lock is designed with tolerances such that you have to either, you've got two options here. You can either get this key pin division here up to the shear line at the core, or but you can get this one here up to the division at the master ring and the Bible. You can't have a mixture of both, okay? You can't get this pin down here and you can't ram this one right way the hell up there. You either got to do all six like this, or you got to do all six like that. So let's take a look at the maths of that. We have got 8 possible situations this time, and I'm not going to go through them in detail, but you guys can work it out. You know, you could be all at rest, or you can have this binding, or you could have that at that shear line, or you can have this binding, or you can have, right, okay, so you can see how that works. All right, so here we go. We have got 8 possible states for this chamber to be in this time, okay? And to open with the change key, you've got to get every single one of them set at this spot here. So your chances of that happening are 1 times 1 times 1 times 1 times 1 equals 1 over 8 by 8 by 8 by 8 by 8, which is 1 in 32,000 and some change. Now just remember, when we were picking it, let's say with this thing, our chances were 1 in 243, okay? Just adding this master ring takes the numbers up to 1 in 32,000. That is why this thing is so much more secure. Now, just to be thorough, okay, and just to be absolutely clear on this, we could decide that we were going to pick to the master ring as well, okay? So if we could do that, the chances of getting that happening are exactly the same as this. So we've got 2 times that. So your actual chances of picking to either one of those two is actually 1 in 16,000. Now, I don't know about you guys, but I will take 1 in 16,000 for security above 1 in 240 every single goddamn time, okay? It is just so much more secure, it ain't funny. Now, here's where I think this gets absolutely fascinating, guys. You really can't rake that, okay? It is virtually impossible to rake those kind of numbers, all right? I guess it could be done, but you'd have to be raking so long with so much energy that the chances of you doing it are just astronomically small, okay? So it isn't really possible in the real world to rake this lock. If anybody's ever raked one of these things, believe me guys, I'd love to know of it. Now the second thing is, we talked about the locks leaking data at you, okay? Believe me when I tell you, I am reasonably good at picking pin tumblers, okay? And I can interpret feedback as well as the next man, and probably better than a lot of them, okay? The data, the feedback that this thing leaks back to you is fucking unbelievably difficult to interpret. Now, it is possible to do. So if you work on this long enough and you are subtle enough with your tension and your understanding of feedback, there are guys that can do this, and it's a similar sort of situation, in fact, to the small format interchangeable chords. Some guys can pick to the change key, some guys can pick to the control. So it's not impossible, all right, but the data is so much harder to understand and so much more difficult to get A, the pin states right, and then B, know what to do about that once you know what the pin states are, that it makes this lock, the old Folger Adams mogul, incredibly difficult to pick. Not impossible, okay, so you know, guys can do it, and I've picked other ones of these. In fact, there's a video of me doing it earlier on in my history somewhere. But all things considered, gentlemen, if you had to pick a lock, if you had to choose a locking system that you needed good security with, robustness and mastering capability, then the mastering system, gentlemen, is the one for you. Thanks for watching that one, guys. I know it was a long one. I know there was a shitload of mathematics in there and a whole lot of technical talk about data and pin states and energy and all the rest of it, all right? But I hope you guys learned something. I hope you enjoyed it, and I'd love to hear your comments in the doofer below. Thanks for watching, guys. I appreciate your time watching this one. My name's Michael Maynard, and this is Gorilla Picking.